Hello guys, welcome on Tesla Adventures. In this video we are going to discuss the axis pressure in the case of multiple radius of curvature. So let us discuss a liquid film whose shape is like this and it has two curvatures. One is this and one is this. You can see that obviously I've drawn this diagram here, that the curvature radius of this curve is R2 and the angle made by this arc at the center is d theta, and the curvature radius of this curve is R1 and the angle made by this arc at the center is d alpha. Okay, and obviously therefore we can say that this length will be R2 d theta and this length will be R1 d alpha. Okay, now let us see that this force, if we imagine this force F1, this is the force acting on these molecules by the neighboring molecules. This total force is F1. So this F1 force can be written as 2T, where I am assuming that there are two free surfaces. This surface has both side air. The air is present above it and below it. So F1 is 2T into the length of this arc, which is R1 d alpha. So this is R1 d alpha, and the F2 is this force, and this will be 2T into R2 d theta. Okay, now if we draw this surface, this one, so we can see that on this surface this force F1 acting on the both sides is pulling this surface like this. This is F1, this is F1, and this will be, this angle at the center will be d theta. So this is d theta by 2, this is d theta by 2. This is 90, this is 90 minus d theta by 2, 90 minus d theta by 2. This is d theta by 2. So the force, resultant force of F1 is this 2F1 sine d theta by 2. Okay, now if we draw this surface, this one, so this is this surface, and if we draw the tangent like this, so this surface, this curved surface, this one, is being pulled by this force F2 from both sides. So this is F2 and this is F2, and this angle, half angle, is d alpha by 2. This half angle is d alpha by 2. Okay, and this is 90. This is 90 minus d alpha by 2. This is d alpha by 2. This is d alpha by 2. So this net force is FB, where FB is 2F2 sine d alpha by 2. Okay, now the total force of surface tension is FA plus FB, which will be equal to 2F1 d theta by 2, because for small angles we can assume that sine theta is theta, and plus 2F2 d alpha by 2, cancelling 2 with 2. So this F total will be equal to F1. Now the value of F1 is 2T r d alpha. It is 2T r d alpha, and the value of F2, this is R1, this is R1, yes, and the value of F2 is equal to 2T R2 d theta, and this is d alpha. Okay, now this total force of surface tension is balanced by the force of axis pressure. So it would be P axis into this area. The area of this surface will be length into this breadth. We can assume that it is almost a straight surface, and this is very small, so we can assume it as a flat surface. So the area of this flat surface will be R1 d alpha R2 d theta. Okay, this force is balanced by F total, so we can say that 2T d alpha d theta R1 plus R2 is equal to P axis into R1 R2 d alpha d theta. Cancelling d alpha d theta, P axis is equal to 2T into 1 by R1 plus 1 by R2. This is the formula in the case of multiple radius of curvature, and if the radius of curvature is same like in case of the drop or bubble, so we can say that R1 and R2 are equal. Now in this case we have assumed that the surface has air on its both sides, so there are two free surfaces. But if the free surface is only one, for only one free surface, we can say that P axis will be equal to T into 1 by R1 plus 1 by R2. So this you have to learn or memorize this formula. You cannot derive it at the exam. So you should memorize this formula, and in the next video we are going to start the capillary action. Thank you.